in use of that logistic regression model and assessing the logistic regression and interpretation of the logistic regression model after break. Since so we are already have of course crossed so almost 10 to 15 minutes of the scheduled time, so hence so better to stop here, and let us we have a break for 15 minutes as shown in your or given in your schedule. Okay, shall I stop here for a break, Chetan?
On sir.
ಗೌಡ್ರೆ ಈಗ ಸ್ಟಾಪ್ ಮಾಡ್ಲಾ ಒಂದು 15 minutes ಬ್ರೇಕ್ ಇಲ್ಲ?
ಒಂದು 10 minutes ಸ್ಟಾಪ್ ಮಾಡೋಣ ಸರ್.
ಓಕೆ 10 minutes ಅಲ್ಲ?
ಓಕೆ ಸರ್.
ಓಕೆ, ಈಗ 12:25 12:35 ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ ಹಂಗಾರೆ. ಹಾ
ಓಕೆ ಸರ್.
ಓಕೆ. ಗೌಡ್ರೆ ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಾ ಇತ್ತಲ್ವಾ? ಏನ್ ತೊಂದ್ರೆ ಇತ್ತು? ವಾಯ್ಸ್
ಕೇಳಿಸ್ತಿದೆ ಸರ್, ಸಮಸ್ಯೆ ಇಲ್ಲ ಸರ್.
ಸಮಸ್ಯೆ ಇಲ್ಲ. ಓಕೆ. ಯಾರೊಬ್ರು ಚಾಟ್ ಅಲ್ಲಿ ರೈಸ್ ಯುವರ್ ವಾಯ್ಸ್ ಅಂತ
ಸ್ವಲ್ಪ ಸಿಸ್ಟಮ್ ಸ್ವಲ್ಪ ರೈಸ್ ಮಾಡಿ ಸರ್, ಸ್ವಲ್ಪ ಅದು ಕೇಳ್ತೀವಿ ಸರ್.
ಓಕೆ. ಅಲ್ಲ ಎಲ್ಲ ಬಾಗ್ಲಾಕೊಂಡೆಲ್ಲ ಹೊಟ್ಟೋಗ್ಬಿಟ್ರೆ ಗೌಡ್ರೆ
ಹಾಂ ಸರ್.
ಕಮೆಂಟ್ಸ್ ಮಾಡೋಣ.
ಓಕೆ ಸರ್, ಓಕೆ ಪ್ಲೀಸ್ ಸರ್.
Okay. Okay, I welcome you all of you once again for the second session. Okay, that's for related to this logistic regression. we have defined logistic regression, and also we have noted how the logistic regression overcome the problem of the linear regression, that is the linear probability model. And also we have uh, discussed with how a logistic regression model is constructed or specified. Okay, so then the method of estimation of that logistic regression model, that is the maximum likelihood estimation. So once we have specified a logistic regression model, so then the next step which follows after specification, as you are noted in methodology of econometrics, is estimation. So then model assessment and interpretation and testing uh, the hypothesis, and finally also testing whether our estimated model is the met the assumptions for that particular model. The same is also used for this logistic regression analysis also. So hence our next discussion is related to so that is the estimation. So then the model assessment, then interpretation of the estimated regression model, if our model is best fit based on that criteria. So then finally we should have to test our hypothesis, and then checking whether our assumptions are met by our estimated model or not. So for that purpose, of course, here I make use of some outputs from SPSS, and in some cases from Stata. Okay, Stata, and here is an example related to that estimation. Here we make use the SPSS for that. So this result is related to our earlier example related to the probability of cholesterol disease with the age. So let us assume that this is the derived result of our estimated result of that problem. So where your regression or the logistic regression model is the probability of okay, the probability of y is equal to y given x. Y is the probability of the cholesterol disease, given x means the age of the persons. Okay, age of the persons, which is equivalent to, that is 1 divided by 1 plus minus beta naught plus beta 1 plus ei or ui. That is our original regression model. And now we have estimated the result for that original regression model by that SPSS, and these results are of course subsumed or incorporated to that model. So that's why instead of beta naught, our estimated value of the constant is minus 5.3. Beta 1 is the estimated value of the beta 1. Okay, estimated value of the beta 1 is 0.11. Okay, 0.11 x1. So this is the values which you have estimated for that model, and this is the result given by SPSS. So before getting to interpretation, as you already noted, that we should have to check or test the fitness of the model, or assess the model fit. So to assess the model fit, one way is, so this is the results which we have obtained, and the diagrammatic representation of our logistic model of that estimated values of minus zero point 0.3 for a constant and 0.11 for the coefficient. So by looking the S curve, or by looking this logistic curve, the logistic curve fits well to our data, because that is approximately that passes through the data points. So then how do we confirm this? How do we substantiate this? So for that, let us change the values of our constant and beta coefficients. So instead of minus 5.3 and 0.11, okay, 11, so let us change the values of that. So now the one value here is, instead of x, we choose the value of x as 0.05, and instead of 0.11. Okay, 0.1. Actually, our estimated value of coefficient of x is 0.11, but instead of here we use 0.05. So if you use 0.05, your curve like actual. This is the actual values, observed values, the observed values of your way. That is the probability of the cholesterol disease. Okay, but whereas your fitted curve is this, so there is a deviations from this. So by observation of this, this is not a good fit. This is not a good fit. That's why by changing your estimated value of the coefficient, so and observing the diagrammatic representation of that, so n 0.5 is not a good value, it is not a best value. So then one more, instead of 0.11 now we put as 0.40 0.40. So your curve is looks like this again. This is not a good one. So by just changing your estimated values, you are able to assess the the fitness of your model. So only your estimated value, that is 0.11 point, sorry 11.11 is a good fit, is a good fit, good fit. This is why one kind of the model assessment. And in statistical analysis, this is called as robustness. That means by changing our estimated values, which model best fit to our data. So here we have three values: 0.11, 0.05, 0.40. Out of these three values, only our estimated value is best fit to the model, and hence our model is best fit to the data, because which is very close, our estimated curve, our estimated logist model, that best fit, that actually passes through the actual values or the observed values of your dependent variable. So then the next is between the model comparison. Okay, between the model comparison. So now let us take, so how to compare the two models. So in case of this logistic model analysis, comparing between the two model, we have to make use the log likelihood ratio test for that purpose. Here you have two models. One model is called as a full model, the other one model is called as a base model. So this log likelihood ratio follows the chi-square distribution. Okay, it follows the chi-square distribution, and the 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 mechanics of estimation of this chi-square value of the log likelihood ratio is like this. It is the 2 times of LL log likelihood of nu and the log likelihood of the baseline model. That means you should have to estimate the log likelihood ratio of two models, that is model 1 and model 2. So the one is full model, the other one is the reduced model, and you should have to take the difference between these two and square that difference. That gives you the chi-square estimated value, and you should have to compare this chi-square value with the table value, and the decision rules are as usual. So let us assume that here we are one more example, and along with any statistical package. So this is the stata earlier I have told you that. So the log likelihood value is given along with your results. So this is the LR chi-square value, LR chi-square value, and the probability of that chi-square value. So the calculated value of the chi-square is 54.11, and its probability is 0.0. So since it is probability 0.0, means your model is best compared to the base model. Compared to the base model, your full model is correct. Full model means, of course, the base model and full model. In case of this model comparison purposes, the base model is you are estimating your logistic model with only B naught or the beta naught, only with intercept. The full model is including all the explanatory variables. So hence the full model is a model which includes all the explanatory variables along with the constant. The base model is a model which includes only the constant. So if you reject the null hypothesis, that is, there is no differences between the full model and the base model is your null hypothesis, or there is no improvement in your estimation, there is the your null hypothesis. So we are rejecting that null hypothesis of there is no difference between the two models. So if you, since we are rejecting the null hypothesis of there is no difference between the full model and the base model, which indicates that our full model is better compared to base model. So this is the another model assessing analysis or model assessing criterion. So the same is given here. Earlier I have told you that full model is a model that includes all the explanatory variables along with the intercept. whereas the reduced model or the base model is only that include beta naught, beta naught. So this is related to the model comparison analysis based on likelihood ratio test. The same is given. And in SPSS, so you have a result like model. It is statistically significant here because the chi-square value is 29 for that probability of the cholesterol disease. So this test is and associated with the significance value, since the calculated value is 29.310 and the probability is 0.000. Hence you have to reject your null hypothesis of no difference between or no betterment. So but there is a betterment in the estimation by including the explanatory variable in your model. Hence your new model is, or full model is, a best model compared to a base model or reduced model. This is the interpretation which you should have to draw from these results of SPSS. So then the next is the R square value, and we are not calling here as an R square or goodness of it. It is a pseudo goodness of it, or a pseudo R square, because there is no direct way to derive the the goodness of fit of the model in case of all the qualitative dependent variable models. Hence statisticians have indirectly derived the goodness of fit of the model. Hence it is a pseudo R square, and the formula to calculate the pseudo R square for the Logit is the same. That is the full model divided by the reduced model. The reduced model here also called as empty model or the base model. It is just taking the ratios of these two, so that gives or produces your value of the R square, And one of the important point which you should have to note here is that, or bear in your mind, is that always the qualitative dependent variable models R square is smaller than the quantitative dependent variable models, because this is not a direct way to estimate the goodness of the fit. So it is only a pseudo in nature. Hence always it is smaller or lesser compared to the quantitative dependent variable models. So this is regarding the second criterion to assess the overall fit of the model. And then of course just like to your multiple or quantitative dependent variable model, the value of the pseudo R square always and also lies between 0 to 1. And of course the Cox and Snell, the two econometricians, opined that this estimated value of the pseudo R square cannot theoretically reach to 1, but that has been adjusted and corrected by the one more econometrician named Nagelkerke, and he has adjusted this estimated value of the pseudo R square that reaches 1. And these are the of course the issues which you should have to study by using this value of the R square as or a pseudo R square as a goodness of fit of the model in case of the qualitative dependent variable models like Logit model. And the next one is the predict. Earlier we have noted that the first one is related to in the overall fit of the model. It is the model comparison. The second one is related to the pseudo R square. The third one criterion for overall model fitness is related to predictiveness of the model, predictiveness of the probability. So in case of SPSS, that gives you like this. In case of a table called a classification table, that is the overall percentage, it is 74% here. So we predict, or the model predict 74% correctly. So that is the probability of cholesterol disease in the selected observations or the selected samples by 74% correctly by your model. That is the way which you should have to interpret this overall percentage, or which is equivalent to predictive power of the model. Predictive power of your model is 74%. So this is related to model assessment or model fit of the logistic regression. So then after estimation of the coefficient, assessing the model fit, the next is interpret. This is the most important part of our discussion, that is interpretation of the regression coefficients or the interpretation of the logistic regression. So in case of interpretation, here we have the three things. The one is the direction of the coefficients. The second one is the significance of the coefficients. The third one is the magnitude of the coefficients. So the direction is related to whether your explanatory variables have a positive effect on the probability of your dependent variable or not. Then the the second one, significance, whether that effect of the direction is significant or not statistically. And the third one is related to the degree of the relationship or the degree of the effect, the magnitude of the effect. So we should have to take into consider all these three aspects in interpreting our result. So these are the 3 points related to this interpretation of logistic regression, and also same is holds good in any regression analysis, including your quantitative dependent variable models. And in interpretation of the coefficients related to the direction, this is the Logit model. Okay, this is the Logit type, and this is the odds type. In terms of odds, it is. In terms of Logit, it is. Earlier we have noted this is the mathematical representation of logistic form of the logistic regression and odds form of the logistic regression. So in case of the logistic form of the logistic regression estimated coefficients, the original estimated coefficients, that is the B, reflects the changes in Logit. That's why your interpretation of the coefficients of the logistic regression model is, that is the changes in the Logit. So that is a 1 unit change in your independent variable. The amount of change in the dependent variable should be interpreted as the changes in the Logit. That means the natural log of the odds. For example, since it is related to the direction of that coefficient, if your coefficient B is greater than 0, which implies that the positive relationship or the positive effect of the independent variable on the dependent variable, that is your chosen independent variable has a positive effect on your Logit value if the value is greater than 0. And if it is less than 0, it is negative. If it is less than 0 means if the B is less than 0, which implies negative relationship. Whereas in case of odds related interpretation, it is an exponentiated B. Means first you should have to estimate the Logit form of the coefficient B, and we should have to exponentiate it. Hence, the odds is, or to obtain the odds ratio of your logistic regression, you have to exponentiate the B, the coefficient of the logistic regression. And the interpretation is that you should have to interpret this in terms of the changes in odds. So that's why in case of the logistic form, it is the changes in the Logit, whereas in the odds form, it is changes in the odds. How to obtain the odds values from the Logit coefficients? You should have to exponentiate your coefficient. If the exponentiated value of B is greater than 1, you should have to imply, or you should have to interpret it as a positive effect. That's why carefully observe here. So if your B is greater than 0 in case of Logit coefficient, it is positive effect. If it is less than 0, negative effect. Whereas in case of odds related interpretation, if the exponent of your estimated coefficient B or beta is greater than 1, implies the positive relationship. If it is less than 1, it is negative relationship. It is related to direction of the relationship, because we know that in all types of regression analysis, the direction of the effect is only positive or negative. But whereas in case of our quantitative dependent variable models, the direction of the relationship has been observed by sign, plus or minus. Whereas in case of this logistic regression model, where we have different forms of the results, so we need to know about the different forms of the directions, different forms of the values of our estimated and their directions. So hence, if we are using the logistic regression results of the parameters or the estimated coefficients, so if the estimated coefficient is positive, then it is positive effect. If the estimated coefficient is negative, it is negative effect. Whereas in case of odds ratio related interpretation, if the exponent of that logistic parameter, the logistic coefficient is greater than 1, it implies the positive effect. If it is less than 1 means if it is start with 0 point, then it is a negative effect. Negative effect. So this is related to direction. Okay, the direction, and related to the magnitude. Related to the magnitude by using, because even in case of use of the magnitude, the same two results we will get. One is the results of the logistic result of the Logit regression, the result in terms of the odds ratio, results in terms of the odds ratio alike to your directional interpretation. The slope coefficient b is interpreted as the rate of change in the log odds as x changes, which is not very much useful for practical purposes. So that's why how to interpret that coefficient of your logistic regression, your logit regression. The b or the coefficient is interpreted as the rate of change in the log odds, because your dependent variable is in terms of the log odds. That's why the rate of change in the log odds as x changes, x might be increases or decreases. So that's why you should have to interpret the rate of change in log odds as x changes. That is the way which you should have to interpret the magnitude of the logit model. Whereas in case of odds ratios, in case of odds ratio, it is as already noted that is an exponent of the b is the effect of the independent variable on the odds, because now your dependent variable is not the natural log of the odds, it is the odds itself. That is the pi divided by 1 minus pi. So hence it is the effect of the independent variable on the odds, and which is more useful for calculating the size of the effect. That is the magnitude of the effect can be easily calculated and easily interpreted by making use of this odds ratio for magnitude purpose, size of the effect purpose. So this is the interpretation in terms of the direction of the effect of your independent variable and the magnitude of the effect of your independent variable on the dependent variable. So now here we have one stata output related to a gun example, that is owning a gun by the people or not owning a gun by the people. So this is related to American economy related data. So whether a person is owning a gun or not, that is determined by several factors like gender, like their level of education, their level of income, and also the region. So, for example, the south and the north, whether the south and the north households have the same probability of owning a gun or not. So there might be some differences. Then whether they are liberally thinking or not. So like this. So in this illustrative example, the determinants, the factors influencing on owning a gun or not is taken into account by the gender, their level of education, income, the region as one, or the location or the region of the person, and the whether he is liberal or not. So, and the results. That's why in case of the stata, you should have to write a command like this: logistic. So logistic means you are running a logistic regression. That is the command which you are giving, and the dependent variable is gun, owning a gun or not. So here probably one is owning a gun. So that's why your dummy variable, your dependent variable is gun, owning a gun, and the independent variables are male, education level, income, the region of the person or the household, and the liberal, comma, coefficient. So you should have to write a coefficient because this is related to logistic regression. Logistic means logit model. This is the coefficient in the previous relationship, and in the relationship of direction and the magnitude b earlier you have seen. So this is the b's, that is the estimated coefficients. So okay, then the interpretation of these coefficients of this gun, owning a gun model, raw coefficients, that is the betas, show the effect of 1 unit change in x on the log odds. Earlier we have already noted when y is equal to 1. So for example, if you take the level of education, so then the effect of the education effect of 1 year of education on owning a gun, on owning a gun. So as the we theoretically expect as the level of education of a person increases, so the person owning a gun decreases. So hence we expect a negative sign for this. The beta or the coefficient of this education should be negative. Whether it is negative or not, empirically you should have to look into the results. So of course the result of education is negative. Whereas the result of the male is positive. That means the probability of owning a gun by male is greater than compared to female. So, and having a higher level of education or an extra year of education, the owning a gun reduces. But whereas the income, as the income of the person increases, owning a gun also increases. So compared to north, the south people guns, or the probability of owning guns for south households compared to north households in America. So if the person is liberal, more liberal, owning a gun is less. So that's why in case of this Logit regression, okay, Logit, that is the natural log of the odds regression, the direction of the relationship can be observed as usual in case of your multiple regression model by observing the sign. If it is positive, your independent variable has a positive effect on the dependent variable. If it is negative, your independent variable has a negative effect on the probability of occurrence of your dependent variable. Here in our illustrative example, the probability of owning a gun is our dependent variable. So hence the probability of owning a gun is more for males compared to females. The probability of owning a gun decreases with increase in education level. The probability of owning a gun increases with increase in income level. And the probability of owning a gun is more in case of the households in south compared to north. The probability of owning a gun is less for the liberal minded persons compared to conservative minded persons. So this is the way which you should have to interpret the Logit or the natural log arts direction. Then the magnitude is this much. The magnitude is by the value of this coefficients. Of course, the same is given here. Hence, I don't want to again get into the each lines for these slides. Each line of these slides. And of course, as we are already noted that in selection of the coefficients for interpretation, whether we should have to choose log arts or the arts. So the better is the arts compared to log arts. That's why the best way to interpret the logistic coefficient is the exponentiate them. The exponentiate them means we should have to use the log, or you should have to use the odds ratio results for interpretation than the log odds, because the log odds we converted that into the simple odds by taking exponentiate them or taking the inverse of that natural logarithm. So this is the way which you should have to interpret them. Okay, so then, and there are some other examples like, do you drink coffee? One indicates coffee drinker, zero indicates no coffee. Key independent variables here, for example, here in grade program. So then observed raw coefficient is, for example, 0.67. It is one more illustrative example. Say positive effect because the sign of this B is positive. Each year increases log odds by 0.67, but how big it is really? So for that, how big it is really means to measure the magnitude of the effect of your independent variable, you should have to exponentiate that. So then the exponentiated value of this 0.67 is 1.95. So how to get manually this exponentiated value of this in your calculator, scientific calculator, you have a button e to the power x. So you have to use that e to the power x in your calculator. You will get 1.97 per 0.67. So now odds increase multiplicatively by 1.97. If a potential odds were 2, for example, So then it is 2:1. An extra year of school would result in this for almost 4 times of increase in drinking coffee. So that's why the interpretation of the coefficients of the logistic regression model is not simple as in your case of OLS regression. You should have to practice it by reading the empirical papers. So this is of course related to interpretation of the logistic regression in terms of log odds and in terms of odds ratio. In terms of the odds ratio, hence I don't want to get into this. And of course, so the many paper hint is many paper present results as raw coefficients or odd ratios. That's why if you go through the results of the empirical papers reported in journals, so there are two ways. So some papers reported the raw coefficients. Raw coefficients means the log odds. Some papers represent, or some papers or the some researchers report odd ratios. So hence it is important to be aware that what you are looking at. So whether you are looking at log odds or whether you are looking at odd ratios. Then how to know that the reported results are log odds or reported results are odd ratios? So I think so I will show you a result for that. So from our owning a gun. So as we are noted that this is owning a gun. So owning a gun related results. These results are, if you obtain a coefficient in the column related to the second column in the results, this coefficient is log odds. This coefficient represent the log odds values. So only for this log odds values you have both negative sign and the positive sign indicating the direction of the relationship. If the results are in terms of the odds ratios, all the estimates are, all the values are only in positive terms, only in positive terms. So only in positive terms. So here it is. So the first one is the coefficient, the second results are odd ratios. In case of say the stata, in case of stata, so the results itself titled with coefficient and odd ratios. As just I have told you that in case of odd ratios there is no question of sign for that, all are positive. So it is in terms of the probability. So for example, related to interpretation of the odd ratio for male, so the probability of owning a gun by a male is almost double compared to female, because the odd ratio is 2.18. 2.1 is 8 represent 1, that is represent say 2 times higher than the females. This is the way which you should have to interpret the odd ratio, which is you have to interpret the odd ratio. So whereas in case of education it is less than 1. So less than 1 you should have to treat it as a negative effect. The direction of the relationship, the direction of the effect of education on owning a gun is negative, which can be seen here, which can be seen in case of coefficient. But whereas in case of odd ratio the sign is not given. But how do you have to identify the effect is positive or negative? By observing the magnitude of the odd value or the odd ratio. Since it is less than 1, if it is less than 1, you should have to treat it as a negative effect of that particular variable. But you cannot you cannot directly interpret it is 92% or 93%. It is not 92 or 93%. So you should have to make some correction. It is inverse of this you should have to write. That inverse means 1 divided by 1 minus this probability value, 1 divided by this estimated value. So that is the negative coefficient will always yield a ratio less than 1, as or the below 1, as less below than 1 earlier. I have told you that. So okay, the same of course are given. So the positive coefficient make y is equal to 1 more likely, negative coefficient means less likely. It is the less likely to own a gun. So that is, so if the education increases, that is the persons are less likely to own a gun. That is the meaning which you should have to interpret for that education effect. Okay, and in the similar way you should have to interpret the result in the interpret the results of the other variables for that owning a gun or not owning a gun. And of course, I will send all these slides. You will go through related to interpretation of the other variables and also the other forms. So better to stop the interpretation of every variable in our illustrative example of owning a gun or not. So I will get into the next part of our discussion, that is related to say. Okay. So in terms of the percentage also, you can interpret your results, but to convert it in terms of percentage, so you should have to exponentiate your value, subtract that exponentiated value from 1, and multiply that exponentiated and subtracted from one value by 100. That gives you this. So for example, in case of education, so 7.38% lower arts per year, arts per year. So that means for every additional year of education, the persons who are having in one additional year of education, so their odds is lesser by 7.38%. So that's why I've told you that. So there are different ways to interpret the results of this logistic regression or the probability regression also. It is in terms of log odds, it is in terms of the odds, also in terms of the percentage like this, and also in terms of the marginal effect dy by dx form. So only the dy by dx form are comparable between the different dummy dependent variable models, more specifically between the Probit and Logit model. That means you cannot directly compare these odd ratios or compare log outs of odds with the results of the Probit model. So only in terms of marginal effects dy by dx form, the Probit models and the Logit model results are comparable. Okay. I hope this is suffix for you at this context related to interpretation. So in terms of the interpretations, thus far we have interpreted the direction of the relationship and the magnitude of the relationship by taking both the coefficients of the logistic regression model. That coefficient represent log odds values, and the other one is exponentiated value of the coefficient, that is equivalent to odds ratio. Only in case of coefficients related results, you have a direction of the relationship that can be observed directly as positive and negative values for the coefficient, whereas in case of odds ratio, the signs are all the odds are only in positive terms. So based on whether the odds value is greater than 1 or lesser than 1, based on that you should have to decide the direction of the relationship and the magnitude of the relationship. So you should have to interpret in odds ratio. If the value is greater than 1, it is that much of the times which is higher than that, otherwise it is lesser than that. Okay, lesser than that. So this is for interpretation. Okay, the same, of course, I don't want to get into this. So then the predicted probabilities, the other one, the predicted probabilities. So whether our model predict, because predict means, for example, related to the cholesterol disease, what is the probability of having a higher risk of cholesterol with the age of 20 years, with the age of 40 years, with the age of 50 years? So we need to calculate that. So then to calculate that probability of a given value of the x is called as predicted probabilities. So by making use of these values of the predicted probabilities also, we can assess our model. And that is the interpretation. For example, related to our owning a gun, so having a education of 11 years, what is the probability of owning a gun, or how much that less likely of 11 years of person, 11 years of education, or having an education of 11 years, then that person is less likely to have a gun. Or with a education level of only 5 years, with an education level of 10 years, or an income level of 10,000 rupees, and what is the probability of owning a gun with that 10 thousands of income rupees? So this is related to predicted probabilities. So that means we are able to predict the probability of our dependent variable with the given values of x's. That is your independent variables. So we can also assess our model based on that predicted probabilities that can be calculated like this. So this is the probabilities. So that is, it is calculated for this is for male is for male it is 0. So then for it is a 7 points. Okay, so 77. Okay, 7.6. It is having education level of 20 years and the income of 40,000, for example. And if the person is belongs to north and is liberal, it is in terms of points, graded points. So like this, so you should have to input the your estimated values of all the coefficients with a given value of your chosen variable. Then you are able to predict the probabilities of own a gun or not own a gun. So it is the probability for a female PhD student. So female PhD student is an highly educated from the north, and she is also liberal. So hence, so yes, I have told you that for female it is 0. That's why here the 0 is assigned for the male coefficient. And in case of America, it is the 20th year in their education, she becomes the student in PhD. So that's why it is 20. So then the income of that student is $4,000, for example. So then she is, belongs to northern states of America. Hence it is 0 for north, 1 for south, and liberal. So in terms of the Likert scale, probability is 7. So then by including all these estimated values of the independent variables along with their actual values for that given person, we are able to calculate that this is -4. That means, so that is the predicted probability. That is the owning a gun by this female likely by an amount of 4. And if you use that for this one, that finally that reduces to 0.11, like that. These are the things which you should have to in case of interpretation of this results. Okay. And there are various other things. Okay, there are various other things related to sensitivity and specificity of the prediction. They are given by the results. We need not to get into here because I already told you that. So that the interpretation of this model assessment is somehow cumbersome compared to our linear models. Okay, then hypothesis testing. So the same method of hypothesis testing you can use. That means, for example, the education has no effect on owning a gun, and alternative hypothesis is education has influence on owning a gun. And there is a difference between owning a gun between males and females,
ಈಗ
males and hello, males and females. So the same way of one tail test and two tail test we can use for testing hypothesis, even in case of the qualitative dependent variable models, are more specifically logit model. So the same is in case of hypothesis testing. So then the model fit, that is the log likelihood test, which are already noted that. And of course these slides related to our the owning a gun or not. So in that, okay, in that year, okay, okay, the same. Okay, here I already told you that log likelihood is calculated, then squaring that, and that is the log likelihood ratio here. This indicates that with the 5 degrees of freedom, our model which we have fitted for owning a gun is a best model compared to the base model or a reduced model. So that's why just by observing this the logistic ratio, whether your model is best or not can be interpreted. And since the value is the probability value is 0, 0, 0, and it is significantly a better model compared to other model or the lower model or the base model. That is one, the comparing the model. And the second one is pseudo r square. So our pseudo r square value is 0.8 plus, and the model, the interpretation is that the model explains roughly 8% of the variation in the y variable, that is our dependent variable. And as I already told you that there is not much importance given, need not to give an importance for this pseudo r square value like in our quantitative dependent variable models. And once we have assessed our model in terms of the model comparison and also with the predicted probabilities and also with the pseudo r square, the last but not the least is whether our estimated model satisfies our assumptions. So here also we have a problem of serial correlation, the problem of heteroscedasticity, and so on. So the same okay, the methods which we have discussed in the previous classes by Niranjan or myself or Prem Kumar. So you should have to use the same methods even for the logistic regression, for whether our estimated regression met the assumptions or not. Met the assumptions or not. Okay, this is about the assumptions and the problems related to those assumptions. So there is the problem of multicollinearity, problem of heteroscedasticity, and serial correlation. And in Prem Kumar class, I think you are already noted that if there is high multicollinearity among your independent variables, your estimates are inconsistent, and also they are inefficient, and also they are unstable. That is, they are sensitive to changes in the values of the number of the observations and also the number of the variables. So we have to check that multicollinearity problem by using VIF, that is the variance inflation factor rule, or by the tolerance rule. So if there is any multicollinearity, you should have to correct it. If there is any serial correlation, again you should have to correct that serial correlation also. So and if there are outliers or influential variables in your influential observations in your model, so again, so that distorts your results, just like your OLS, you should have to correct those outliers or omit those outliers from your model model. Okay, so then one of the important point, of course, in any even in case of dependent variables, the quantitative dependent variable or a qualitative dependent variable, so there should be a sufficient variance in your dependent variable. If there is no sufficient variation in your dependent variable, your results are not robust, your results are not valid, your results are not valid. For example, extremely rare events can be a problem. Suppose out of 100 observations, 1000 observations you have, only 3 are coded as 1, 997 are coded as 0, then the estimates are won't be great. So that means they are not reliable, they are not believable. So that's why there should be much variations in the value of your dependent variable. You should have to have a larger number of values for both the value y is equal to 1 and y is equal to 0. That is, a sufficient variance is required for estimation, or a good estimates are the best estimates. And and also maximum likelihood estimates cannot be computed if any independent variable perfectly predicts the outcome. That means, so if you have several independent variables, out of that several independent variable, if any only one independent variable correctly or perfectly predicts your dependent variable, that is the outcome of the dependent variable. That is also one of the problem. That is called as a dominant variable problem. So due to because of the dominant variable problem, so the results are not much reliable. Like this, the same kind of problems which you have faced okay, or encounter in ordinary least square method, here also the same kind of problem you will face. You should have to check for them correct if they are present in your model. So this is related to the model assumptions and corrections of that model or the logistic model. So this is a brief discussion on the logistic regression analysis. So uh, to summarize my discussion related to that, the logistic regression analysis. The logistic regression or the Logit model is one of the most popular models in estimation of a dummy dependent variable model, or a qualitative dependent variable model, or binary choice models. So this logistic regression model specifies the log odds, not the probability. So the probability is converted into odds, then odds values are transformed into natural form or natural logarithmic form. So by why, of course, we need to convert the probabilities into odds and the odds into natural natural logarithmic form. The reason is, only reason is to confine the predicted probabilities between 0 to 1. This is the major problem which we have seen in our earlier method of estimation, that is LPM, that is the linear probability model. So that's why to estimate the probability values only between 0 to 1, the logistic regression model transformed the probability into odds values, and finally that transformed into natural logs. And we can also obtain the odds values from the natural log of the odds by inverse natural log, or exponentiating the natural log odds. Hence, the results given by the statistical packages or in the estimation, we can obtain both the log odds values and the odds values. Out of these two, the odds ratios are more convenient for interpretation, and only by using that odds values or the odds ratios, the magnitude of the relations can be interpreted. So hence, in case of the interpretation of this the logistic regression model, better to use the odd ratios than log odds, than the log natural log odds. And the method of estimation which we need to use here is the maximum likelihood estimation, because the logistic model is a nonlinear regression model. Hence, we cannot use least square method. And further, in case of the interpretation, our the way of interpretation in case of logistic model is actually in three forms. The one is the direction of the relationship. The second one is related to the magnitude of the relationship. And actually the third one is there. That is the marginal effects. Marginal effect. That marginal effect is equivalent to the 1% change in your independent variable and its effects on 1% of the dependent variable. That cannot be directly again obtained from this logistic regression. So we need to make use of that calculus, especially differential calculus, and the computer statistical packages provides that marginal effects also, marginal values also. And finally, to assess the estimated model itself before interpreting our results, we should have to compare our model estimated with the base model. For that, here we have to use that is we have to use the log ratio, the log ratios, or log likelihood ratios, log likelihood ratio given by most of all the statistical packages. And the second, the model assessment is by using the pseudo r square value, and the third one is by our estimated predicted values. So if our model estimate certainly or accurately the predicted values of the probabilities, then we can treat our estimated model is a best or a good model. So then the last but not the least is this logistic regression model is also based on assumptions like no autocorrelation, no heteroscedasticity, no multicollinearity, no influential observations or outliers, and so on. You should have to test all these after your estimation to make your results more valid, So these are the things which we have been discussed from last almost 1 hour related to logistic regression. Hence, I stop here my discussion related to logistic regression. And if you have patience and if you have time, based on your your side or your opinion, so I ask you whether shall I continue my session for another two types of say the dummy dependent variable models named Probit model and 2-bit models. So now shall I continue for another half an hour? Chetan?
Huchagowda, sir. Sir, are you able to
Huchagowda.
hear, sir? Huchagowda, sir.
Rangappa sir.
Even Rangappa, sir, is online, sir. Sir, I'll just call Rangappa, sir, and... yes, sir.
Both of us are here, Chetan.
Yeah, fine, sir.
Yeah.
Sir, actually, since it is now 1:30, so I need another half an hour for a brief discussion on Probit and Tobit models. That's why I've asked the opinion of the participants. Shall I continue? And from 1 or 2, like Dinesh Kumar and one name MI9 mobile number, they asked me to continue. Okay, me to continue. Shall I continue for another half an hour, sir? Ragappa, sir?
Sir, continue ಮಾಡಿ sir, please.
Continue ಮಾಡಲಾ sir? Okay.
Participants are willing, no problem. Let it complete.
Okay, sir. Okay, sir. Okay.
Right, sir. Right. Thank you, sir. You can continue, sir.
Okay, sir. Okay.
Right. Thank you, sir.
Okay. Let continue. Okay. Okay. This is of course these slides. Okay, these slides are taken from one econometric book written by Christopher Daughtry. Okay, book of econometrics books. It is more of in equational form and also in diagrammatic representation. So hence, to make my presentation here as brief as possible, as compact as possible, hence I have taken the slides from the Christopher Daughtry book. And of course, this book is a reference book for the students of London School of Economics. So if you open the London School of Economics department web page related to applications of econometrics related paper, so the only reference book is this Daughtry book. Okay, so just this is for your information. So as we were noted when we are discussing about logistic regression model, the another best alternative to the LPM model is Probit model. So that's why we have only two best or the better alternatives to LPM. The one is Logit model, equivalently the second one is Probit model. And again, this Probit model can be applied for multinomial and ordered type of dummy-dependent variables, the panel type of data also, but the simplest form of this Probit analysis or the Probit model is for a dependent variable which has two categories or binary choice types of models. The difference between that Logit and Probit model is in terms of the distributions. As we were noted earlier in related to Logit model, the Logit model follows binomial distribution. Logit model follows binomial distribution, whereas Probit model follows normal distribution. That's why the one of the difference is in terms of the distribution itself. Hence, of course, from this slide, you are observing the curves. For example, this curve, this is a bell-shaped curve. The bell-shaped curve is a normal distribution curve. But to estimate the probability of happening or occurrence of your chosen variable, a dependent variable, so we cannot directly use that normal distribution. Hence, that normal distribution is converted into a cumulative normal distribution. So that's why this curve, the next curve, this curve is a cumulative normal distribution curve. So why we need to make use of this cumulative normal distribution instead of normal distribution? So you know that in case of standard normal distribution, so the values that can be taken by your z value is both negative and positive. So because, so if it is a standard normal distribution, you know that the mean value of the standard normal distribution is 0, and the left to that 0 is negative values and right to that is positive values. But whereas in case of our here, so we should have to have only positive values. Hence we here we should have to use the cumulative normal or standard normal distribution, cumulative standard normal distribution. And now in case of this cumulative normal standard distribution, under this probability analysis, now we should have to have a new latent variable, or latent variable. Of course, now first time I'm using this latent variable. That is also what is good in case of say the Logit model, because the true outcomes of your qualitative response variable is not observed in practice. So hence we should have to create a dummy variable, and a synonymous name for that is in literature is called a latent variable. And now we have defined that latent variable as z here, and this z as a function like this, and this function is a normal distribution related function. So that's why the point here is that the logistic regression model follows the binomial distribution, and the probit model assumes the normal distribution, and within that normal distribution, so here that make uses of the cumulative standard normal distribution. So where we have defined a variable called z, and z is a function of your independent variable. And again, to estimate the parameters of this probit model, the maximum likelihood estimation has been used as like or like to the logistic regression. Okay, this is just an example, results of that probit analysis, results of the probit analysis. It is the coefficient of this probit analysis. So whether a person graduating or not graduating, whether a person that is joined to a graduate school or not, that depends upon several factors: the mother's school, the father's school, and a person being a male or a female, and their average score in the previous education, high school education, for example, in this case. So that's why, so here the dependent variable is the graduate education, whether a person is graduated or not, or whether a person is enter into graduation or not, that depends upon their average score in the previous examination, and their mother's education, father's education, and also the a person is entered to the graduation. This differs between male and female. That's why we have also taken into account the gender as one of the factors influencing on that. So in case of the stata, so there you have written a command like logistic. Now you have to write your probit followed by the dependent variable and the independent or explanatory variables, and the results looks like this. And here also you have the same kind of log likelihood ratio test. The log likelihood value, calculated value of the log likelihood is 44, and the probability value of that is 0. That means your model is statistically significant. That is, the model is a best fit, because you are rejecting your null hypothesis of no difference between a base model with the new model, or a full model with a reduced model. Hence, based on this log likelihood ratio test, your model is a better model. So then the value of the pseudo r square is 0.18 plus. So it is 18% of the changes in graduation, or your model explains the 18% of the variation in a person being graduated or not. So this is the interpretation of this log likelihood ratio and the probability of that, and the pseudo r square. So that's why these statistics are similar to your logistic regression model. There is no difference in the method of interpretation also, but the only difference is in terms of this, because these are in terms of the z values, because here we have used z distribution, standard normal distribution or standard normal cumulative distribution. So that's why you should have to interpret only in terms of that. And the direction is directly observable by this, because here are plus or minus. So plus represent the, that is the probability of graduation or joining for graduation increases with the previous educational ability, that is the marks or the grade. That's why it is positive. But the that is the males, okay, the that is the mother's education, this is okay, mother's education. If the mother's education is as a negative effect on the graduation, that means if the if one additional year of mother education, that leads to decrease in the graduation of that student, whereas the father education has a positive effect. So being a male, he is more likely to graduate compared to the female. So the same kind of directional type of interpretation is also used in case of this Probit model, but the interpretation of these values are not similar uh, logistic regression. This is it is a z score. These are the z score. Hence, so you have to interpret like this. So the average, okay, the average previous grade is increases by 1 unit, then the z score is increased by 0.6. So the the one additional year of mother's schooling as reduces the graduating of a person by a z score of 0.08. That's why you should have to use that z score every time for interpreting the value of this coefficient in case of this Probit model. So this is the only difference between the Probit and Logit models in terms of the interpretation. And the second, earlier we have noted, is in terms of the distribution of your variable, that is the standard normal distribution. Hence the z value is given here, and the probability of z is followed after that column. And of course the same as given in the below of these tables of how to interpret the results. And this is the marginal effects, okay, the marginal effects. Earlier I have told you that how to use that marginal effects interpretation. So it is the partial okay, change in the probability of being a graduate with respect to xi variable is, so schooling of mother, schooling of father, and the previous exams average grade, and the male. So the xi represent all your independent variable. So that is the part of change in the probability because of change in every independent variable. So they are called as marginal effects in general, both in case of quantitative dependent variable. The same is also in case of qualitative dependent variables model. And only based on these marginal effects, as I earlier told you, that the models are comparable, that the results are comparable. So that is the result of Logit and the results of Probit models are uh, comparable. And also the OLS results are comparable with these two only by using the marginal effect, because I hope in Rangappa sir's class we have noted the quantitative dependent variable models coefficients are called as partial coefficients, because they measures okay, the part of change in the dependent variable because of change in the values of the independent variables. So to derive that partial concept or the partial coefficients, so here we should have to again use that differential calculus, and it is estimated by this equation, that is the dp by dz. This represent, that is the marginal effect of xi on P can be estimated by the marginal effect of probability of Z, or the marginal effect of Z on probability, and the marginal effect of X on Z. So by taking the multiplicative nature of these two, you would get the marginal effect of the probability of being a graduate due to because of the father's schooling, mother's schooling, or our age, previous grade, and so on, so on. So this is the way which we use this marginal effects for interpretation in case of probit analysis, and also you can use the same kind of analysis in case of logit analysis, and mostly that is used in practice for comparable purpose of comparing the results of probit and logit model. And this is the mathematical technicalities of this the marginal effects. Okay, I don't want to get into that. Okay, but to compare the results of probit and logit models along with the OLS. So we should have to take a multiplication of these marginal effects with the probabilities and so on. So for that, of course, here there are some results are given. So this is the one 550 persons are taken into consideration, their mean values for every variable, their standard deviation, minimum and maximum values. So they are just these are the summary statistics of our variables. Okay, variables. So then this is the mean values of the variables. This is the coefficients which we were estimated earlier, and the product of these two is given here. Product of these two given here, and the total of this product is 1.821. So in this case, it is equivalent to 1.1 when the x variable are equal to their sample means. So to obtain this marginal effects, so the marginal effects are calculated based on the mean. So and also the marginal effects can be calculated based on the median. But so in your interpretation, whether you have used mean for marginal effects calculation or median you have used for marginal effect, you should have to mention, or you should have to report that point, whether you are using mean for calculation of the marginal effect or whether you have used the median for calculation of this effect. That's why the marginal effects are simply the products of the mean values of the variables with the estimated coefficients of the model. That is the only one point which you should have to just bear or note this point in your mind. So then based on this, finally the f of z, the marginal effect is calculated. And and of course from SPSS you would get all these things. So that is the product and the f of z, this f of z, and this f of z with the product, that is the estimated marginal products are f of z multiplied by the respective coefficients. So we see that 1 point increase in that average grade in the previous examination increases the probability of grading from high school by an amount of 0.4. So now you are interpreted in terms of the percentage. So that means only by making use of this marginal effect, you are able to interpret in terms of percentage. That wise, so due to because of he is having a higher score in the previous class, the probability of graduating is increases by 0.04%. That is used by this is f of z. So this is multiplication of this marginal, the f of z function with this probability. Hence the computation of this calculate marginal effect is so cumbersome. Hence even in practice, as I have earlier told you that in your in most of the papers which make uses either probit model or logit model, especially the logit model results are are more popular in practice. So they results only the coefficients or the odds ratios, not of marginal effects. So because to derive that marginal effects, you should have to take the mean value, you should have to multiply that mean value with the coefficient, and you should have to take the product of that, then convert this product into a z value, and that z value should be multiplied with your coefficient, and that value is a marginal effect value. So and by why we need, of course, this marginal effect, as I already told you that, so that is equivalent to your dy by dx. That is 1 unit change in your independent variable. How much your dependent variable changes can be interpreted even in this logit and probit models by using this marginal effect. Only for that purpose the marginal effects are calculated and used in practice. So okay, this is about, of course, the probability analysis, and these are the results of Logit and Probit model. So as earlier I have told you that whether you use Logit model or Probit model, if your sample size is large enough, there is not much difference between the results. So this result is for our illustrative example of graduating a person or not graduating a person. Just observe that the marginal effects are more or less same, but the coefficients are different. Because as why the coefficients are different, the method of estimation of the method of estimation of Probit model is different, the method of estimation of Logit model is different, then because of that the coefficients are different. But the marginal effects are are comparable, because we have make a modifications accordingly to compare them. So, and by observing that marginal effects, because f of zb is a marginal effect and they are comparable, and there is not much difference between the Logit model marginal effects and Probit model marginal effects. So in that sense, just I have, of course, as I have told you and mentioned when I have started my discussion or introducing this qualitative dependent variable. So one leading authority in econometrics, Amemia, Amemia. So Amemia, he has mentioned that there is no compelling grounds for preferring Logit to Probit and vice versa. So that's why, so you need not worry in practice whether you have used Logit model or Probit model, because there is not much difference between the results of Logit and Probit model, Logit and Probit models. So hence, I hope you might have been seen in practice, in the literature, in the articles. So both are using in practice. So and there is no any rule of thumb uh, to prefer or to decide which one is better compared to another. So that is given by Amemia. Okay, I think this is the discussion, a brief discussion on Probit analysis. And now we have a linear regression model for the same variable. So here you have found the difference between the estimates. So the average earlier grade effect is different, and all, of course, all the coefficients are different in linear regression or the OLS regression compared to Logit and Probit model. Hence you cannot continue to use linear regression for this grading or that is graduating from a school or not. So this is a brief discussion on, okay, brief discussion on the Probit model. So to summarize on this Probit model, the Probit model is another alternative to the Logit model, as equivalent as the logistic regression in practice to estimate a qualitative dependent variable models. The difference between Logit and Probit models is in terms of the distribution. The Logit model, okay, uses the binomial distribution, whereas the Probit model make uses the standard normal distribution or the cumulative normal distribution model. And the method of estimation is there also maximum likelihood estimation. The Probit model also make uses the maximum likelihood estimation, but the mathematical procedure is significantly different, because I hope many of you know the equation which is used to estimate a normal distribution is distinctly different from a binomial distribution. But the results which we have obtained uh, for our results, for our problem, between Logit and Probit model are not much differ. So if you take, if you if you if you compare the results of the Logit and Probit model in terms of the marginal effects, as we have seen just now, so there are not much differences, So hence, one leading authority in econometrics named Amemia, he mentioned that, so there is no any rule of thumb to prefer one to another. So Logit to Probit or Probit to Logit. Hence, hence the researchers can have their own selection. They can use Logit model or Probit model. So this is a brief discussion on the Probit analysis or Probit model. Then last but not the least, is related to Tobit analysis. For that Tobit analysis also, I have taken the slides from the Christopher Daughtry econometrics book. So of course here we have 37 slides. I don't want to get into the mathematical technicalities of this, and also uh, in detailed discussion related to okay, detailed discussion related to this, the difference between the Logit and Probit model and the Tobit model is that. So in case of Logit and Probit model, so we have selected a variable, a dependent variable with a qualitative in nature. But there are some situations, there are some variables. So those variables, okay, those variables have some
Hello.
sensors.
Yeah.
They have some truncated in nature. So let us, of course, directly, I go to an example.
You run out
So
of your data.
hello, okay. So we are running out of our time.
No, sir. No, sir. I mean,
No,
please you continue,
no.
sir. We have enough time.
Okay. So this is of course a hypothetical, okay, an hypothetical regression estimation, and the observation of that has been okay, derived from with an assumption of the normality assumption of the disturbance term with a mean value of 0 and a standard deviation of 10. And based on the derived values of the x with a mean value of 0 and the standard deviation of 10, we have observations like this, and we have estimated a regression like this. This is a linear regression or a OLS regression. So by observing this, okay, you have noted that they are evenly distributed. Okay, some are less than 0, some are greater than 0. But whereas we have one more illustrative example. So the distribution of your observations are looks like this. Earlier it looks like this. They are distributed across all the values of your dependent independent variables. But whereas here, especially the dependent variable here we are taking into account. So here your value of the dependent variable is censored with a given side tail. It is into a left tail. So it is in the left part. That is, the most of your observations are 0, and the sum of your observations are positive values. So that means so the dependent variable which you have been selected for your analysis, you have observations which are censored with some specific value. In this illustrative example, they are censored with the 0 values. Only after this point and onwards, there are some positive values over after 30 and adds. But up to 30, your values of the y is equivalent to 0. And this is known as the censored observations. So if your observations are censored like this, either to the left tail or to the right tail, or either to the left part or to the right part, left part is closer to the lower limit, right part is closer to the upper limit. So that's why you have two kinds of censored: lower censored and upper censored. Here it is a lower censored. Okay, so if you have such a lower censored type of or upper censored type of observations, so if you run your OLS estimation, your OLS estimation is underestimated. It is downward bias. Your coefficient is biased towards downward. So actually your OLS should be a solid line like this. The dotted line is your OLS. So it is underestimates your coefficients. So that's why we cannot use your OLS estimation for this type of models, this type of censored data. So then what is the best alternative? The best alternative is the Tobit model. The best alternative is the Tobit model. The Tobit model taken into account this censored observations. So it uses the two steps. The first step, it uses both the 0 and 1. The next step uses only the positive values of the regression, positive values of the regression. Okay, positive values of the regression. So that is the difference between the Logit and Probit model and the Tobit analysis, the Tobit analysis. So okay, the same by giving the different values. I don't want to get into all this. So why we have this problem? Because why we have underestimation? Because so there is a large variations in your value of the disturbance term that are highlighted here. So that is that goes on changing, by goes on changing the value of this. So we are able to account all these variations in our censored variables. So the same is shown diagrammatically like this. So I don't want to get into this part. Okay, I don't want to get into this part, and here is an example: the household expenditure by the households on consumption expenditure. So here we use the consumption expenditure survey data to illustrate the use of Tobit model. This figure shows the annual household expenditure on household equipment, that is HUK, on the total household expenditure. So out of their total expenditure, how much the household spent for the household equipments. So both of these two variables are measured in the dollar terms. So by observing this, so most of your variables are censored towards the lower limit, censored towards the lower limit, or the lower limit with the lower levels of income. That is the lower limit. So then in case of this strata, if you estimate only tabulate this out of the total number of observations, 80 of observations, 96, okay, 86 observations have a zero value means so they have not at all spent in their total expenditure to purchase household equipments. So here you have seen that. So the 86 households HQ was 0. The tabulation has been confined to the small values of X, and we are only interested in finding out how many variables. Okay, how many out of many actually, which is 0. So this is only an illustrative example. In many case practice, there are several observations that confined to the value of 0. So then this is the normal regression or the linear regression. This is the estimated value of the expenditure, the effect of expenditure on the household expenditure. So it is 0.7. That is, if the total expenditure increased by 1 rupee or $1, so out of that only say 0.47 dollar has been spent on household expenditure, and it is expected to be downward bias according to our expectation, because so there we have noted that 86% are households. Out of the total households, they are not at all spent on the purchasing the household equipments. So hence we are expecting a downward bias in our OLS estimator. So then that can be compared. Okay, this is the final. So this is the Tobit results. These are all the regression results. Comparing the estimates of these three, so you have been observed that the coefficient of Tobit model is higher compared to this. Though of course in our illustrative example, it is not very much significant, but in practice, so if you have a large number of variations or the large number of persons who are censored towards a particular value, the variation is significant. So hence, so here the Tobit results are differ with the OLS results. Hence you cannot use the your OLS estimation to estimate these kinds of results or these kinds of data where your data is censored towards or the truncated towards only a particular end with a lower end or a upper end. Okay, this is a brief discussion result related to Tobit model. Tobit model. So the Tobit model was developed by our say the James Tobin, the economist, econometrician. Okay, so and he proposed this model, and hence the model is named its own name, that is the Tobit model or the Tobit analysis. Okay, this is about the Tobit analysis. To summarize my discussion related to the Tobit analysis, the Tobit analysis, the Tobit model is a special case of a dummy dependent variable model where your variable is censored towards a particular value. So in such a situation, your ordinary least square method is not appropriate because the estimates of the least square method is downward biased. Hence, we should have to use the Tobit analysis. The actual procedure of the Tobit analysis include the two steps. Two steps. So actually, it is a combination of two steps. The first step uses Probit analysis. The second part of the Tobit equation is a linear one. Linear one. First, that uses the probability of being. For example, if you take the participation of female in labor force, participation of female in labor force. If you take 1000 or 1000 female persons, okay, out of 1000 female persons, so you might have obtained say the some of the females are not in the labor force, some are in the labor force, and the factors influencing on a female person or a female in the labor force, that determined by their level of education, their family income, their social status, and so on. Okay, so then to decide whether they are participating in the labor force or not, so you should have to run first Probit model. So then why only the few persons with the same characteristics? So they have education, they have also a same level of social status and the same other characteristics. Even then, why some females are participating in the labor force or why are not? To answer for these types of questions also, you have to use Probit model. So for a comprehensive type of discussion and analysis, you better to go to the literature or econometrics books to learn about this Tobit analysis. Okay, this is about the Tobit analysis, and in the today's class, we have been discussed about the qualitative response variable models, all types of qualitative response variable models. Only for the binary choice models we have been discussed, not of multiple choice or multi-cotomous variables or ordered types of models or panel models. So the same kind of models can be extended into any other types of dummy dependent variable models. So this is my summary of the today's class or sum up of my today's class. So I stop at this point. So if you have any queries or questions or doubts, so you can ask me. And of course, I am unable to get into show you the use of course, the stata for this. If you give me another 5 minutes, I will show you that. So better, because somebody has chatted, okay, in a chat he has written to show these estimations in SPSS, but I use okay, the stata for that. Okay, and okay, where is mine? Okay, let me show you the use of stata for estimation of the Logit and Probit model. Okay, Logit and Probit model. So for that, okay, okay, 1 minute, whether I had a stata here or not. I don't much. Okay, I didn't have stata here. Oh, okay, stata is there. Okay, stata is there. Okay, now I open stata. This is the home page of stata. Okay, then I have a example file. Okay, example file. Okay, that example file. Okay, this is the Logit model data class. Okay, Logit model data class. So just I have my data in my Excel sheet. Okay, data in my Excel sheet. Okay, I just uh, copy. Sorry. Okay, just copy these variables. So where whether the person is willing to work or not, that depends upon their level of education. Okay, I think we have around 4,000 observations. Okay, 4,000 observations. 4,000 observations. Since I am copying all 4,000 observations or 4,000 persons, whether they are employed or not, whether they are working or not. So that depends upon their level of education and whether a person is male or not, female. That is there any difference in the person being an employed or not, influenced by the gender? So for that, we have also included one more independent variable, that is male. So hence, in our data, we have, okay, we have the employed or not, or labor force participation or not, depends upon two variables, level of education and the gender. Let me take only part of this data. Okay, it is I will select 2,500 persons. Okay, 2,500 persons. Okay, 2,500 persons. I copied this from my Excel sheet and I directly pasted it to okay, pasted it to stata. This is look like your Excel sheet. Directly I have pasted it. Okay, directly I have pasted it. Okay, not, sorry, 1 minute please. Not copied. Sorry. Sorry, because I don't know why it is not. Or can I directly import? I will checking. Oh, permission denied. Okay, okay. So worksheet one. Okay. So okay, the data is imported. Okay, the data is imported. We have a data here. Oh, sorry. Okay, because the title I have to delete this. Huh? Okay, values. Yes. So okay. Uh, I have to change. Okay, the name of the variable since directly value the labels. Content. 1 minute, please. Excel spreadsheet. Yes, I made a mistake earlier. Okay, open Logit model. Since I have not first row as a variable name, because first row is variable name. Otherwise, it treat the first row also as a string variable. So that's why the mistake which was made by me is I was not selected that import the first row as a variable name. So then, okay, the data ID. This is the work, whether they are working or not, or they are in the labor force or not, whether they are willing to work or not, whatever the traditional way we are estimating the that is there are expected, or we are expecting whether there is a difference in the males and females, between the males and females for their labor force participation. So because of this analysis we have selected these three variables, and just observe that this is our labor force participation rate, that is a dependent variable with a values of 0 and 1. So 1 indicates the participation in the labor force, 0 indicates not participate in the labor force. So this is the interpretation of your independent dependent variable. And the education is number of years, a quantitative variable. The male is again a qualitative independent variable, 0 for say female, 1 for male. So this is the description of our data. So then in case of stata, as of course you have seen in my class related to the slides where I have shown, directly you can type here, directly you can type here, that is the logit. Okay, logit. Then dependent variable, you need not to type the value of the name of the dependent variable. Just you have in the right top corner of this home page, you have a name, all your variables. Just go to the first variable. There is a dependent variable. There is a left arrow mark is there. Just click on that. Automatically that variable appears in the command window. So here it is the second independent, first independent variable, second independent variable. Okay, so this is a command window here. So I have running a logit model. Dependent variable is labor force participation, education, and male. Okay, after this just enter button and just press the enter button. The results are appears here. This is the maximum likelihood estimation is always an iteration process or iterative process. So hence we need not worry about that iteration. Based on that iteration, the best value of our estimators are given by the maximum likelihood estimation. So these results are similar. These results are similar as we have seen in my slides, class slides. So the log likelihood ratio value is this much. The log likelihood value, okay, of the square of that is okay, this much. That is the log likelihood for model comparison is that 247. It is the probability of the 247 is 0, 0. That is the model which we have estimated is a better model. It is a better model, and the value of the R square is pseudo R square is 0.05. That is only 5% of variation in this joining participating in the labor force is explained by our model. And this is the coefficient. Earlier I have told you that both as a positive signs, both as a positive sign. That means the direction of the relationship is positive. As the level of education increases, the participation in the labor force also increases. And being a male, the participation of labor force is positive compared to female. But as I already told you that you cannot use directly this estimator coefficient. This is a log, like this is the log odds, log odds. Since the magnitude cannot be interpreted easily by using this one, so hence we should have to estimate the log that is the odds ratios. So how to estimate odds ratio from you need not to use that mathematical procedure, that is exponentiating them, and by using that exponentiating them you would get log that is the odd ratios. Whereas in case of this say stata, instead of typing logit to obtain the log log odds, just type logistic, okay, logistic. So logistic a space dependent variable followed by independent variables and press enter. So now it is odd ratios, so in terms of this it is like this, okay. It is be for every additional year of education, the participation in the labor force is 17 times, because you should have to use 1 point, this 1 point, this 1.17. There is a 17% of higher participation in the labor force for every additional year. So you need not to take, because if it is 1, if the odd ratio is 1, there is no change. If the odd ratio is greater than 1, so the amount of that difference after 1 you should have to take in terms of the percentage. So it is like this. So 17% is higher for every additional year of education in participating in the labor force. Whereas for male, it is 167%, because 1, you should have to subtract this value from 1. Then it is 2.67 minus 1 is 1.67. So that is 1.67 means in terms of it is 167% of higher for males, or the males are 167% of higher participation in the labor force compared to females, and both are statistically significant. Because the probability values of these two coefficients are 0, 0, 0, 0. That's why education has a significant effect on the probability of participating in the labor force, and also the probability of being a male is also significant in participation of the labor force compared to females. So this is the way which you should have to interpret your result, okay. Interpret your results of a logit model. So for probit, so just type probit instead of logit, that's all. Probit instead of logit, so you would get the results for that. So that's why it is very simple to use stata compared to any other statistical package. So because it is so user friendly. So to learn about this use of stata, you better to read the manuals of stata, or for a quick type of use of this stata, you just for example click help button and search, and for example, so you type logit, so then all the logit related and other estimations comes here. So if you go to logit regression, okay, so then if you just click on this logit, all the descriptions given how to use this logit in stata is given here. So likewise, so you should have to, okay, sorry, you should have to use that logit stata for your any purpose, not only for this logit or probit models. So you can use it for any type of models. So for probit, for example, just type probit. So instead of probit, just type probit here, probit, okay, just type probit. So that gives you the results of probit model. But to use this probit model, so earlier we have noted that, so it is lower less, so then within that you should have to 0. So sorry, it is 0. Oh, okay, 0. So then enter the button. So because we have sent, if it is centered 0, that means it is censored towards 0. So out of this total, okay, out of this 400 and total, so the sensors were only 8, for left censored were 845. That means, so out of total okay, I think 500 households or 500 persons. So 845 persons are not participated in the labor force, and remaining are participate in the labor force. So that is the meaning of deficient sort, and this is the results of this Tobit model, results of the Tobit model. So I think I stop at this point. So if you have any doubts, so you can contact me through my email address given in our university website, or you can call me to my mobile number. So my mobile number is, if you have need my help, you please write down my mobile number. My mobile number is 94804383 94804383. Okay, I repeat once again, 94804383. Okay, with these words, I wind up my class. So, and we have one more class, I think day after tomorrow, related to RIMA related models. So we will meet on I think the Thursday. Okay, we will meet on Thursday at 10:30. So okay, thank you one and all for your patience listening from 10:30. So almost 4 hours. So thank you one and all.
Thank you very much, sir.
Thank you, sir. Thank you very much, sir.
Yes, sir.
Now I request Megha to propose vote of thanks. Megha?
Megha,
Yes, sir, I'm here.
Please, ma'am.
Yes, sir. Well, now we reached the fog end of today's session. Here, my words are not enough to gratitude on behalf of Economics Department and Research Scholar Forum. By heartily, I would like to say thanks to Professor Mahesh sir. Sir made the session very informative and very worthful to all of us. So thank you so much, Mahesh sir. And also, I would like to extend my special thanks to our chairman sir and to coordinator and to all my faculty members of Economics Department for organizing this online workshop. Thank you. And also spread my thanks over dear participants and research scholars for their participation and for their patience listening. Thank you and all. Thank you.
Sir, thank you, sir.
Thank you, sir. Thank you, Uche Godre.
Thank you, sir. Thank you very much.
Okay, thank you, sir. Angappa. Sir. Okay, thank you, one and all.
Chetan?
yes, sir. Shall I end the meeting, sir?
Okay, please.
Yeah, fine, sir.